Joe Clark from Aviation Partners. Your company does winglets, and winglets was one of those things that just started to show up on the scene not too very long ago. Tell us about the winglet technology and what it does for the airplane.
Okay, well actually we started in 1991. Our first airplane was the Gulfstream II. But to give you kind of a layman's look at it, winglets are a more effective way to put on wingspan on an airplane. And what we do with an existing airplane is we take the vortex that goes off the tip of the wing and we gradually use that vortex up and we take it away from the flatter planar part of the wing and put it way up high and much smaller. So it lets the airplane slip through the air better, much like turning a big ship into a hydrofoil. That's kind of how, from a layman's standpoint.
And then what does that do for the airplane? How does it affect the performance?
Well, typically on most airplanes that we've put winglets on, we achieve between a 5 and 7% drag reduction. So it really does a couple of things. It lets you fly further on a long-range jet, 200 to 300 to 400 miles further. For example, on a 757, it's 42 minutes more range with no additional fuel. On the other hand, if you decide to fly the same mission, you're saving about 5 to 7% fuel.
Freedom through performance. At Cirrus, performance is not simply the measurement of a single design parameter. Rather, it's a total package. It's optimum balance of speed, efficiency, comfort, safety, ease of flight, and quality. We call it Cirrus Flying 2.0. Aren't you ready to feel the freedom?
Where did the idea come from? Who first thought about taking the tip of a wing and curving it up to make the airplane work better?
Well, that was a gentleman by the name of Whitcomb. He did that, I believe it was back in the 60s. And the reason you haven't seen more large winglets like we've made and shaped differently is they did most of the studies in wind tunnels. And we didn't ever use wind tunnels. We used the actual shapes. We took an airplane, flew it baseline, got all the data on it, fitted our prototype winglets like they used to do back in the 60s, and flew those same points, and we measured the delta.
It seems like it took a little while for the technology to catch on. What do you think was the cause for that? What is it now that we're seeing a lot more airplanes with winglets?
Well, I'll give you an example. I went to see Alan Paulson when we wanted to first do the Gulfstream II almost 20 years ago, and he said, well, what do you want to put winglets on a G2 for? It's like putting hubcaps on a Cadillac. And I said, well, we think we have a breakthrough where we could get, and we ended up getting over 7% on the 7.33% on the Gulfstream. And that's kind of how it all started to begin with. Now, initially the company, my partner had a G2 and he wanted to put G3 winglets on it to make it perform better. And we came up with a new design.
And so did it take a while for the industry to come around and say this technology really is working and it will make our airplanes more efficient?
Right. We're in a very conservative industry and the not invented here factor is very large. Most of the manufacturers, including Boeing, Airbus, Gulfstream, if they didn't invent it, it doesn't exist. So when I first put winglets on airplanes, nobody believed it would work. And there would be, if you had 10 aerodynamicists in a room, 1 would believe it worked and 9 wouldn't. Now it's the other way around.
The beauty of the Release 9 system architecture is that you have 2 fully redundant integrated flight displays. Each has access to all the systems and data. Providing full redundancy and eliminating traditional reversionary modes, Release 9 allows either display to be configured as the PFD. Now your failure modes are much more manageable because you can continue to fly with the same familiar display symbology without the need to relearn composite modes you don't typically fly with. Avidyne's Integra Release 9 is truly the next generation in fully integrated flight deck technology.
What is the certification process like for an airplane to have it outfitted with winglets?
Well, it's a pretty difficult certification process. It takes us about 12 to 14 months after we fly the prototype. We go through all the FAA protocols. We have to do a complete flight test on it, do all the stress analysis, structure, loads, etc. So it's a pretty robust process.
And how many airplanes are your winglets certified for at this time?
Well, we're certified for 16 different types. We're on just under 4,000 airplanes now, and we are doing about, between our joint venture with Boeing and our Aviation Partners, Inc., we're doing about 550 airplanes a year now.
So what are you looking for in the future? How do you see this technology progressing, and what is it doing for not only airplane performance, but the environment?
You know, it's kind of interesting. I believe anytime you can take an existing asset and improve the productivity and performance, it's a wise investment, and you're making it eco-friendly at the same time. So you could take an existing airplane and add winglets to it, and if you can save 5 to 7% in fuel, that's why we're as successful we are in the airline industry.
Joe Clark, thanks for taking some time to talk with us on Aero-TV.
Okay, thank you.